Hi everyone. Today we are going to do the next part, means part 5 for vectors. In today's class we are going to see resolution of vectors and then unit vectors. See, resolution of vectors plays an important role in whole physics. Whenever it comes to vector, then resolution really plays a major role in vector. Let's see why we are doing this first. Let's see why we are doing resolution. What is the need of this, that we are going to see first. Think about of that. Suppose if we have this box here, it is placed somewhere here in the ground, right? And then we are pulling this object with a force of 10 Newton at an angle of 30 degree. Now the same object is pulled like this. Now what is the difference? See, when you will pull the object at 0 degree like this, so the block is not going to move, is not going to lose any contact. See, if this is block, if this is the block, then it will move like this, right? If we are pulling at 0 degree angle. But same block, if it is here, then what happens if you are pulling it like this? Now see, it means it is moving in x-axis also, y-axis also. So as force is a vector quantity and it is acting in two different directions, then we should know what is the how much force is acting in two different directions. As we know in Parallelogram's law, we had done that if it is acting in two different directions, right, like this, then we are supposed to find the resultant of the same thing. We'll have to do here also. That we'll have to see that force in horizontal direction how much it is acting, in vertical direction how much it is acting. Then we are supposed to find the resultant of that. That is known as resolution actually. Hope so you guys got little idea what is horizontal, what is component. So let's write the topic name. I haven't wrote yet. We say this resolution of vectors. A resolution of vectors. Let's take more example. If you throw an object, if you throw this object like this, horizontal direction, no problem. If you're throwing at an angle of theta, then you'll have to do component again. Suppose if you're if you'll throw like this, so the velocity we gave is like this, right? If you'll see, this is the horizontal line, then this makes some angle. Then you'll have to find velocity in x-axis, you'll have to find velocity in y-axis. Then you're supposed to find the net of that, then only you will get the answer. Otherwise, you will not get the net velocity. Let's see another example. Why it plays a major role is, I'm looking for something where I can give you some example. Let's consider this is a bottle. Wait, I'll give some example. Yes. Now think, here we are applying force, it is moving, right? Now the same object, if you'll apply force here, it is toppling. Same amount of force you are applying, it is toppling now. What will happen? It will topple, right? There will be a torque. Before it was force. Now it is what? If you change the position, it becomes what? Torque. Good. Now let's say, if you are applying here force, it is moving. Same force, apply at an angle of theta. Now it is not moving. Same force I am applying, but it is not moving because it is acting at an angle of theta. Acting at an angle of theta means that the force is acting in x-axis as well as what? Y-axis. If it is acting in, see, now the force is acting in one direction, then of course the magnitude of the force is going to be more. If the same force is acting at an angle of two different directions, at an angle of theta, so it will act in two different directions, maybe three directions, x-axis, y-axis and z-axis. If it is acting in three different directions, then the same magnitude is going to divide in three, not equally, but kind of, right? So obviously the magnitude of the force, overall force, will decrease in different direction. That is what, that's why we should know that how much force is acting, right? That things we will find in what? Resolution. Resolution, if you want to do, then what I say prefer, like, which is the easy way to do resolution is, whenever theta is attached with any axis, whenever theta is attached with any axis, that axis is cos theta. Suppose this is x, this is y, then we can say the resultant, the force is acting like this, right? And this is theta. So this will be cos theta, this will become sin theta. We'll see by maths. So whenever theta is attached with any axis, that axis is going to be cos theta. Opposite of that is what? Sin theta. Remember one more time what I told. Whenever theta is attached with any axis, that axis is cos theta. Opposite of that is what? Sin theta. Let's see. So we can say, if you are applying a force here in x direction, that force is going to be what? F cos theta. This force is going to be F sin theta. That's it. Let's see how it came. This is theta, 30 degree, right? This is force F, right? Now cos theta, if you will write, cos theta is based by hypotenuse. So let's take, this is x, right? So we can say x by f, f cos theta. See, f cos 30 is equal to x. Now y sin theta. Sin theta is going to be what? y by perpendicular by base, hypotenuse. F sin theta is equal to what? Y. That's it. Whenever theta is attached with any axis, that axis is going to be cos theta. Apart from that is what? Sin theta. That's it. That is what you should know from what? Component. Okay. Let's see now. For more component, like suppose an inclined plane. Component in what? Component in inclined plane. This is theta. Now think about it, that force is acting, one block we kept here of mass m. So we want to resolve like mg force. Let's see. We are so sure that mg is acting like this. You know that mg will act like this, right? Okay. Now let's say this is theta. We are parallelly, we are so sure that this angle is 90, right? Correct? That angle is what? So we can say this is mg, right? This is theta. This is 90 degree. So anybody, we can say that this is 90 minus theta. Very good. Now we want to find horizontal component and vertical component. So guys, we can say directly this is going to be one line. So towards that we can find the component, vertical component. So we can say this total angle is 90 degree. This is 90 minus of theta. Let's take this is x, right? So 90 minus of theta plus of x is equal to 90. So x is equal to what? This x is equal to what? Theta. Okay, let me remove everything now from there. So now we can say this is what here? Theta. Whenever theta is attached with any axis, that axis is cos theta. That's it. That you apply, you'll get everywhere correct answer. Mg cos theta. Horizontal component is what? Mg sin theta. Hope so you guys got it. Understood how to do component. Whenever theta is attached with any axis, that axis is cos theta. Apart from that is what? Sin theta. That's it. Now suppose if you are seeing like this, this is theta, this is force. So we can say this will be what? F cos theta. And this is going to be what? F sin theta. I don't think so. More than this, we need a theory in this. We can do more theories, but there is no use of that. Like you guys understood anyway. Let's do 1-2 questions. So enough for this what? Component. Now we are going to do unit vector. Okay. So unit vector is a dimensionless quantity vector having what? Magnitude 1. Having we wrote already. Having magnitude 1. Having magnitude 1. Right? Let's see. If you want to find unit vector, then what? Unit vector means, I will tell you one best example I'll give you. How we represent unit vector, let's see. Unit vector is vector A by mod of vector B. There is a cap. Put a cap on this, becomes unit vector. That's it. Put a cap on this, becomes what? Unit vector. A, there is a cap here, right? That becomes what? Unit vector. That's it. So unit vector whose magnitude is 1 and gives what? Direction. Let's see how. To become a vector quantity, vector A, if you will write, you will multiply with this. Now the main thing, the interesting thing is what here, that this is not having magnitude is what? 1. Dimensionless vector quantity having magnitude 1. If magnitude is 1, then what will happen? If you multiply with anything with 1, it is going to remain same. So magnitude, right, and the direction, of course, vector, right? That's it. That is what unit vector is. Hope so you guys got it. So unit vector is what? Vector A cap is equal to vector A by mod of vector A. By what? Mod of vector A. By what? Mod of vector A. Now we are going to see orthogonal vectors. Orthogonal vectors. Orthogonal vectors, if you will see, this is obviously x, this is obviously y, and then this is what? Z. X-axis we are saying, we are giving the name as I cap. Y-axis we are giving the name as J cap. Z-axis we are giving the name as K cap. So x-axis is what? I cap. Y-axis is what? J cap. And Z-axis is what? K cap. I cap is what we can write unit vector in positive x direction. J vector unit vector in positive y direction. K cap is what? Unit vector in z axis, positive z direction. Hope so you guys got it. So that is about what? I cap, J cap, and what? K cap. Let's see, a vector has magnitude 5. let's write one question. A vector has magnitude 5 in the direction of plus x-axis. So 5 I cap, that is what here is a vector. Let's take vector is A. Hope so you guys got it. A vector C has unit is 2 units in the direction of minus x. So minus I cap plus what? Minus direction, then minus I cap, right? The same type of question. There is no use of that, right? You can ask a number of questions, but the answer is going to remain what? Same only. So we understood what is I cap, j cap and k cap. Let's see now. One more thing is what here? Whenever you are writing a vector, then vector A by mod of vector A. One question we will do. What is this meaning of mod? Find the vector. One question is there. This is a good question. Find. Let me write the question. Okay. Now the question is what here? Find the velocity vector of a particle moving with 10 meter per second in the direction of vector r. R is equal to I cap minus 3 j cap plus 2 k cap. This we want to find. Okay. So vector r is equal to what we learned? Vector r we learned as mod of vector r and then what? R cap, right? That is what we learned. Fine. Let's see how we'll find mod of r. To find mod of r, guys, as we know, I cap, j cap, k cap, all are mutually perpendicular to each other. So we can say angle is 90 degrees. So directly we can say a square, distance formula you'll have to apply. A square plus b square plus c square root under of that. So 2 square minus of 3 square plus of 2 square root under of that. So 4 plus what? 9 plus what? 4. So 17, right? Root 17. So now we can say that magnitude is how much here? Root 17 we got, right? And then it is given, find the velocity of a particle moving with 10 meter per second. So magnitude is how much here? 10 meter per second. R cap means what? Vector by mod. Vector is what here? 2I cap minus 3j cap plus 2k cap divided by what? Root 17. That is going to be the R vector. That's it. Hope so you guys got it. Is there any mistake we did? I don't think so. 2 square, yeah, correct one, yes. Anyway, you guys understood the concept. Maybe calculation mistake, right? Let's write one question now. Yes. So vector A is 3I cap plus 4j cap, and vector B is what? 7I cap plus what? 24j cap. Find the vector having the same magnitude as B. Okay, let's solve this first. What is that? Find the vector having the same magnitude as B. Okay, so 7 is square, magnitude we are finding, 24 is square, right? 7 is square, 49, 5, something like, it will become around 49, then 24, how much it is? 576, right? So 625, so ultimately it is going to be 25. So that we found the magnitude is how much? 25 unit. Okay, and then what? They are saying that find the vector having the same magnitude of B and parallel to C. So C vector, if you will see, it is going to be mod of C, right? Mod of what? C, and then we can say vector cap of C. So mod of C we got 25. They told that same the magnitude of what? B. Okay, right. And then they told that it's parallel to B. Parallel to B means what? this is A, this is C. We can shift here, right? So same direction. Ultimately they are saying here vector A by mod of vector A. Mod of vector A is how much now? This is, we got mod of vector B. Mod of vector A is 3 square plus 4 square root under of that. So 16 to 5, 20, 25, 5. That's it now, guys, right? So we can say C 25, and here is what? 3I cap plus what? 4J cap by what? 5. So it is going to be how much now? 5. So 15I cap plus C vector, you should write 15I cap plus 20J cap, that is C vector. Okay, let me write here fresh. 15I cap plus 20J cap. So that is going to be the answer of what? This question. I haven't I haven't done many more questions in this, right? We don't need that much here. Maybe we can do more questions on what this resolution. But only one thing you should remember is what? If it is attached with any axis, that axis is going to be cos theta. Apart from that is what? Sin theta. That's it. Unit vector is what? Vector by mod of that. Cap thingy you put, that cap is what? Mod, and then what? By vector by mod of that. Then basic numericals 1 2 we had done. That's it. If you will do here again, we can do 50 questions, but there is no use. That is what in physics we use this, because maths, no, we're not going to, we are not learning in physics. We can do tough numerical that some who will have vector, they will learn in maths, right? Class 12. So till here you guys revise again. We'll have in the next class what is remaining.